Yes, all of you can hear me?
Yes, sir.
Yes. Can anyone sorry, does anyone have any doubts regarding the last session? We have seen something beams by using AISC design and Indian standard design. Have you, any one of you have practiced? If you have any doubt, you can ask me, because we are going into the frames session. So, okay. So everyone is clear. Can I take it as no?
Okay, sir.
Yeah. Thank you. Thank you. Thank you all for joining. Okay. Just let me share my screen so that we'll see today's session. Before going to the session, I have just one idea regarding this methodologies and regarding different types of structures. Okay. Just I am thinking that before we have something time already, we have completed at most 9 or 10 sessions till today. So I am planning to uh, take you as a session like one simple frame with AISA design, one mezzanine frame with Indian standard design, and one crane frame with AISA design, and one flat roof structure with Indian standard design. So like that, like that, I'll shuffle the code methodologies and codes and types of structures. So is it okay for everyone, so that all the codes will be covered and all the structures will be covered? So is it okay, everyone? So first of all, if you are confused with me, just let me tell you. I'll take a simple frame with AISA design in first session, and then next we'll see Indian standard design, the frame with mezzanine, and then next again we'll see AISA design, frame with crane, and we will see flat roof structure or any other structure, BC or BC, something with Indian code design. Like that, I'll shuffle the structures and codes. Is it okay for everyone? So
Yes,
that every people can understand, right?
sir.
Yeah.
Sir.
Yes, tell me.
Sir, screen is not showing me.
Sorry?
Screen share.
No. I have not shared yet. I'm just telling you.
Okay, sir.
So this is my concept. If you have any objection with this, please let me know. If all of you are okay with this, because 50% of the people wants AISC design, 50% of the people wants Indian standard design. So I'll shuffle both the codes and I'll shuffle all these with the different types of structures. So I'm planning to take like that. So okay, right?
Okay, sir.
Okay, fine. Thank you very much for responding. Okay, so I'll start the session today. I'm sharing my screen. Just give me a minute. Okay. Fine. My screen is visible to all of you.
Yes, sir.
Okay, fine. Thank you. So I'm just creating a new structure. Suppose let us take a rigid frame. Whatever the concepts or deflection criteria, effective lengths or something else, design parameters, everything I'll use here. I'll explain one by one each. Okay. So I'm creating a new structure here with the name of rigid frame. Okay. Just let me open one drawing also. Okay, suppose I'm taking this as a plan. Okay, so I'm taking a plan like this. Okay, so the width of the building is 55 meters. Suppose let us take this is an example I'm taking you from the real time. Okay, suppose this is a 55-meter width building. In the length is about 84.5 meters. So all of you are seeing this one, right? My drawing is visible to you, all of you, right?
Yes, sir.
Yeah.
Yes,
Yes,
sir.
sir.
Sure. So one mezzanine is there. Since it is the first frame design, we are doing simple frame design only. So I'm not taking the mezzanine into account in this session. So I am taking just a simple frame like this. Okay, a simple frame like this. Okay, suppose if I take any of the interior frame, suppose let us take a grid line 8 frame along grid line 8. So frame along grid line 8, I have to design now. So what is the type of frame? Can anyone tell? Already we have seen different types of structures, right? And my plan is in front of you. All of you guys can see. So what is the type of structure here? Can anyone guess? One column here, one column here, one column here. So what is the type of frame this one? Already we have seen different types of frames. So can anyone guess?
Dome structure.
Sorry? No. Dome.
Pitch
How can
roof.
we? No. Yeah, it is obviously most of the PEBs are pitched roof buildings only. Okay, we cannot tell that by seeing the plan what type of structure it is. No, actually, no. I am asking about technically whether it is a rigid frame or beam column or nothing but BC column 1, BC1 or BC2 or something. Yeah, type of frame I'm asking like that.
BC1, sir.
Yes, exactly. Perfect. This is BC1 because if you see there is one internal column here. So, okay, these two are mainframe columns, either sides, okay, along this line and along this line. These are called mainframe columns, okay. There is only one internal column. Along one frame line, there is only one internal column. So, this is called BC1 frame, beam column frame 1, okay. This is the type of frame. So I'm taking a frame at grid line 8 and
sir?
I'm going, yeah, tell me.
BC1 or MS1 are similar.
No,
So that,
generally multi-span, if you see, you cannot tell by seeing this. Multi-span is a structure with multiple gables, okay.
sir.
Gable is nothing but a triangular portion. If you suppose, let me take one line here so that you people can understand. Okay, So my BC column frame will be like this. Okay. The top of the BC frame will be look like this. Yes, right. One column will be in between them, right? At this portion, one column is there. Suppose like this. But if you go to multi-span, it comes like this. Two
The
gable.
multi-span or multi-gable are same.
Yeah, multi-span or
Those things are-
multi-gable are similar. This is called, okay, some companies will follow some terminology, okay, depending
Yes, sir.
upon the company. Okay,
Yes.
generally the perfect terminology is that if there are multiple cables. Sorry, I'm getting some disturbance from someone. Okay. Okay. If there are number of cables, the structure can be called as multi-span. If there is only one cable and there are number of columns, that is called as BC columns. BC frames.
मैं तो आप क्लास ले तो नहीं रही थी तो क्लास रिकॉर्डिंग हो जाएगी ना तो छोटी रिकॉर्डिंग हो जाएगी बाकी बोल रही
Okay, fine. So I am taking grid line 8 as a BC column frame 1. Okay. So what is the width of this building? 55-meter width. So and one more important thing in this, what is the tributary of this frame? Suppose I am taking grid line 8. What is the tributary of this frame? Tributary
7.5.
or bay width? Yes, exactly. Perfect. Why it is 7? Yeah, exactly. 7.5. Why it is 7.5? Generally, this is the frame we are talking about, right? Just I'll highlight. Okay. This is the frame line we are talking about, right? Okay, so it will take half portion of length from this, half portion of length from this. Okay, so half of 7.5 takes grid line 8, half of 7.5 takes grid line 8. So half plus half, it comes as full of 7.5. So the bay width or load width or tributary of the grid line 8 will be 7.5. Anyone have doubt in this?
No,
Because tributary is the main concept while applying loads. Okay.
No, sir.
This is the main concept while applying loads. If you take a lesser tributary, you'll get a less weight of frame. Obviously, if the tributary is more in practical way, the frame will going to fail. So that is why tributary is the main portion while applying the loads. So the base spacing, just tell me.
सर एक बात पूछना था, अगर ऐसे ये 7.5 मीटर पूरा सब तो सेम है, मान लीजिए बहुत सारा स्ट्रक्चर में 7.5 मीटर 8.5 मीटर 10 मीटर ऐसे बहुत सारा स्पैन है, तो उसमें किसको डिजाइन करें जो सबसे लार्जेस्ट स्पैन को ही लेके चले ना?
No, the one thing I want to tell you, okay, here it is 7.5 same, but okay, suppose let us take this frame. Okay, this suppose along grid line 3. Okay, along grid line 3, one side of the base space, one side base spacing is 6.3, other side is 7.5. So you have to take the average width. Okay, 6.3 plus 7.5 by 2, like that only. Nothing but half of value from 6.3, half of value from 7.5. And the question you asked is about if there are multiple changes in base spacings, what value we have to take. Okay, if you have time, you can do one frame by one frame. Okay, it's your wish. But if you do not have much more time to do each and every frame separately, you can take higher value tributary frame and you can apply it to the all frames. Is your doubt clear?
Yes, sir.
Okay, if you have time, you can do each and every frame separately by taking the individual bay widths. But if you don't have much time and suppose your client is pressurizing you, you can take higher side and you can apply it to the all frames, but that will be uneconomical. Okay, maybe suppose here the frame width, the low tributary is 7.5. Here obviously it is 6.7 or something, 6.9 like that, right? So obviously there is some difference, 7.5 and 6.9, almost half meter difference in tributary. Okay, so loads will get less in this frame. That is why if you do typical to all frames, sometimes it will be uneconomical. So if you have time, better to go with individual frames. Okay. So I'm taking grid line 8. So average tributary 7.5 plus 7.5 divided by 2. That will give you the average tributary as 7.5. So I'm just mentioning here as a reference only. Just 7.5 meter bay. Rigid frame underscore 7.5 meter bay width. Okay. So please check this feature whether it is in English units or metric units. Okay, whichever is feasible to you, you can follow like that. Okay, generally we follow metric units only. So I'm creating structure. Sorry, it has been closed. I'm advising all of you, please use licensed version, anyone possible, because these are what I can say, cracked versions. Okay, these cracked versions show some negative results. Okay, while analyzing the structure, because some structures may pass in licensed versions, but these structures may fail in cracked versions. Okay, so please be aware that while using cracked versions. So it is better advising that better to use licensed version only if possible. So I have created a structure. So I'm creating an initial node at origin. So I'm taking as front view as reference because I'm doing it. I'm doing 2D frame only. Okay. So we have to increase our learning step by step. So I'm taking 2D frame only. Already we have seen frames, and then we are doing. Already we have done beams. We are doing now frames, and then we'll see space frames. Okay, like that we'll increase our standards. Okay, so first let me copy this node to some width. Okay, what is the width of the building here? So frame is in this direction, right? In this direction. So what is the width of the frame? You can see it is 55 meter. Okay, but in this 55 meter, 200 will be taken by block wall on either sides. Okay, how to give center to center in? Okay, most of generally STAT will take center to center dimensions only. Okay, that is the main point you have to understand. So while giving the width in STAT, you have to give center of this column to center of this column. Okay, so that is why the overall width is 55, but we should not give 55 in the STAT. Okay, because 200 block wall on both sides it is going, and while giving the center line, you have to give your assumption. Suppose let me take the base. The base depth of the column is 300 mm. Okay, so I have to neglect 0.15 because I have to give at the center line, right, in the stack. So I have to neglect 0.15 from the flange. Okay, so 200 plus 150, 350 on one side. So this side also 200 block wall plus, suppose let me take assumption of 300 overall depth of beam at overall depth of column at base plate. That if I take center line, it will be 150. So 200 plus 150, 350. So 350 on both sides. So 55 minus 2 into 0.35. Okay. So how much we have to take in the stat? 54.3 only. All of you agree with me?
Yes, sir.
Clear. So I'm giving 54.3 only in the x direction. So these
Sir,
are
I
the.
have doubt.
Sorry.
Sir, I have doubt.
Yes, tell me.
Sir, this column I have assume depth is 300. Sometimes its depth is more than 400, 450 like
Okay.
this.
Yeah, probably it may go. You have to shift this point after the design if you want.
Okay.
No problem at all. After the design, and if your design has passed, okay, after that, if any change, you can shift this node to something. Whatever the actual dimension, you can shift that node. Okay.
Okay.
Yeah. So these two are sidewall columns. So I have one middle column also here. Okay. This is the column. So this is at half distance. Okay. So 55 by 2 actually, if we take middle of these two columns. Okay. But I am taking here 54.3 by 2, right? So 54.3 divided by 2. So 27.15. 27.15. So these two are mainframe nodes for mainframe columns, and this node is for BC column. So we have created nodes at the base. So we have to project columns and then rafters. Now, so what is the height of building? For that, I'm going to take cross section. Okay. So this is the cross section. Okay. They have given in my project it as 6 meter clear. Okay. Sometimes customer will give clear height. Sometimes customer will give U height. U height is nothing but top of U strut. This is C section you are seeing, right? I am highlighted here. This is called U strut. Okay. The bottom of base plate level to top of U strut can be called as U height. Okay. Sometimes customer will give U height. Sometimes they will provide clear height. I need clear this one. Okay, whatever the U height will it will be, he has no problem. Like that, some customers will be. In my project, he has given 6 meter clear. Okay, so 6 meter clear plus, just I'm again telling you, STAD is taking center lines only. Okay, so you have to give trial dimensions of the columns and beams by trial and error basis. So all these you have to assumption first. So suppose this one 6 meter clear he wants. So this is the rafter. STAD will take center line like this. I will draw. So okay, center line like this. Okay. So this is the depth you need now. Suppose our rafter depth is what is the module width here 27.5. So let us assume my rafter depth is 800 mm. So what is the center line will be 400. So 6000 plus 400. 6.4 you need to take. So clear, on both sides I am taking 6.4 height. Just I'm using Control C and Control V to creating nodes. Okay, copy and paste. Okay, so I have created haunch portions here. Now I am going to take ridge. Okay. Okay. Suppose here slope. Okay. Slope, let us take 1 in 10. Okay. For suppose customer has given the roof slope as 1 in 10. Okay. So what is the distance here? And ridge is symmetrical. All these are assumptions. Okay. Because I'm telling you an example. So 27.15 and the roof slope is 1 in 10. So what is the rise will be? So the horizontal distance is 27.15 meter and the roof slope customer has given is 1 in 10. Okay, 1 in 10, or you can say 10% slope. If you are easy with telling percentages.
2.715.
Yes,
2.715.
2715 mm or 2.715 meters. So horizontal distance is 27.15. Vertical rise will be 2.715. Okay, some of you have may have doubt. I'm just telling you how to calculate it. Okay, 27.15 is horizontal distance and customer is giving 1 in 10 roof slope. 27.15 into 1 by 10. If you do like this, you'll get the rise. Okay, rise is nothing but E to peak. Okay, so 2.715. So thus I have created a node at the ridge. So I'm just adding the I'm just connecting all these beams. Okay, so clear. The next thing, for better optimization, every company will provide you one guideline. Nothing but the column or rafter, if the column or rafter is more than 3 meters, you can divide it as a segments. Okay, segment is nothing but there will be no splice, but they can connect different sections by using welding. Suppose we will do taper here, nothing but outside will be flat and inside will be taper like this, right? Inside will be taper. So you can take one segment. If you take one connection here, there will be one section on the top, there will be one section on the bottom. So for better optimization, you can change thicknesses for top segment, you can change thicknesses for bottom segment. Okay, so company will guide you what to do for better optimization. So actually what we will do is that, suppose what is the length of this one? 6.4, right? So it is more than 6 meters. So I can divide this entire column into 2 segments because each segment should be at least 3 meters. So I'm dividing this column into 2 segments by using insert node feature is there. These options I am hiding. Yeah, it is clear. So I have to select the column and there is one option insert node. So before going to the insert node, what is the start point and end point? If you click Shift E anywhere in the UI, it will show you green and blue colors for each beam. Okay, the green color indicates starting and blue color indicates ending of the particular beam. Okay, so I have to select the column and I have to click the insert node option. And what is the distance I'm going to take? Just I'm taking segment at 3 meters from the top. I'm adding new point. If I click OK, you can see here one beam becomes 2 beams. Okay, so generally in STAT, all these will be called as beams only, because if you see here beam, layer beam, add beam option, so everything will be called as beam only in the STAT itself, because it does not know what is column, it does not know what is beam. So that is why I'm telling you this also as a beam. Okay, so I have divided the entire column into 2 segments, and this also I'm doing as number of segments by using insert node option. So the actual length of the beam from eave to peak is, here it is showing 27.2814. So I'm dividing segment at each 3 meter portion, 3, 6, 9, 12, 15, 18, 21, and then 24. Up to 24 only I can do, because the beam length is 27. 24 plus 3 becomes 27. So I cannot give it 27 meters. So overall beam depth is 27 meters only. Sorry, overall beam length is 27 meters. So if you see here, meters only. Sorry, overall beam length is 27 meters. So if you see here, so number of segments are created. What is the use of segment? If you do not segment the column, you have to give the entire column thickness, entire flange thickness for the column, only one thickness you have to give for entire column. Suppose our flange thickness is 10 meters, so you have to give it to the entire column. But PEB is well known for optimization techniques. That is why you can change the thicknesses for top segment and bottom segment. So for that purpose, I am doing segment wise. Be careful while doing segments. Be careful with the unsupported lengths. What are unsupported lengths and how to use, I'll tell you while doing. While doing segments, this is the most complex portion. If you forget to give any unsupported length for this column, that may cause you problem. How it will cause, I will tell you. Okay, so I'm again clicking Shift E so that everything will disappear, start and ending points. So if you click, if you see here, this is symmetrical portion, so the left side can be mirrored to the other side. So just I'm selecting the nodes by using node cursor. Whatever I have done on the left side, I am selecting the nodes on the left cursor, and there is one option, mirror. Mirror about which plane you want to take. YZ, right? YZ plane. This is YZ plane. So select YZ plane and plane position node. Which about which node you want to mirror. I'm just taking this node. You can take this node also, because any node on the YZ plane can be taken as a reference for mirroring. So I'm taking this node. If I click OK, if you observe, all these nodes created on the right side also. Whatever you have done on the left side, all these will be mirrored to the right side portion like this. Okay, so you can do directly like this. Okay, so if you click Shift B, beam numbers. Shift B means beam numbers. So if you see here, 1, 6, 2, 15, 3, 7, 8, 9, 10, 11, 12, 13, 14, 20, 3, and all these are not in order. Okay, so if you want to make them in order, you can delete all these beams, and it is asking, deleting beams has left some nodes with no structural element. Do you want to delete these nodes? No, I don't want to delete the nodes. I want nodes to be here. Okay, so I'm just adding as per my order, because I know the order. It will be easier if you give beams in order, it will be easier. Okay, just if you observe here, it is 1, it is 2, all the columns will be directly in order. 3, 4, and this column is 5. Suppose let us take. Okay, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So this time I'm giving from this side 15, 16, 17, 18, 19, 20, 21, 22, 23. So what does this mean? Overall 23 segments make a frame, a BC1 frame here. So now all the geometry has been set. Okay, nothing but all the nodes have been created, all the beams has been done in a particular order which we want. Okay, if you want, you can do like this. All the beams can be started with one, and columns after that you can do columns. You can do as your wish. Okay, this is my favorite order, that's why I have done like this. Which order you like, you can do, it's your wish. Okay, properties, materials, all these will be done in the STAD editor. Okay, material, as I told you, material is constant for anything because we are doing steel structures only. I'm assigning material here itself. Sorry, assign to view. If I click assign, all the beams will be assigned with steel material. Okay, so up to this, everyone is clear? This is how to create a geometry for a frame in the STAD.
सर वन डाउट
Yes, tell me.
सर आप ये बीच वाला जो सेंटर में जो कॉलम है उसको तो सेगमेंट में डिवाइड नहीं की
हाँ, कर सकते हैं.
अच्छा
ये भी कर सकते हैं, लेकिन डिफरेंस दिखाने के लिए इसलिए ऐसे छोड़ दिया मैंने.
ओके सर.
Okay, you have to see the difference, right? This we have done by using segments. This we have not done with segments. So it will show you the difference. So okay, after the design, I will segment this one also, so that how it can be optimized. You'll see. Okay, up to this one clear. So I'm just going to the yes, tell me.
Sir, I thought why you given segment? This is not, I'm not getting it exactly. 3 meter. 3 meter means purling spacing or?
No. This segment is completely different from design parameters or unsupported lengths. Okay, I have not given these segments according to the purling lengths or something, purling spacing or something, because the PEB is well known for optimization. You should not give the entire portion of the rafter or column at a particular stretch. Okay, in only one stretch you cannot give. Actually you can give, but that will be uneconomical. If you do segment wise, you may get higher thickness or something, higher depth of the section at this portion. You may get lower thickness or lower depth at this segment of the portion, so that you will get economical section at the final design. That is the main purpose. And why I have given 3 meters, there is one thing. Generally, the transportable length for any column or rafter portion is, the maximum transportable length is, generally in India they may follow 9, and in US they may follow 12. Okay, the maximum, for the example we are taking, the maximum transportable length is 12 meters. Okay, for example, the maximum transportable length of any rafter or column, any portion, can be 12 meters only. So I am taking the 12 meters into different segments, so that suppose the rafter shape will be like this. Okay, like this. I can draw here, I think. So if you see column, oh sorry, it is my mouse is not going, not working efficiently here. Okay, but at this BC portion you have to give flat portion, flat bottom. Okay, so like this you have to give in actual. Okay, at this BC portion you have to give definitely flat portion, because to sit the column properly. Okay, so if you segment like this, I'm doing every part as 3 meter segments. So you can provide different thickness. For example, it has take 8 mm thickness plate for flange or web. It may pass 5 mm web plate or 6 mm web plate here. Thus it will be economical. So I have done these segments for economical purpose only. And that too, I told you maximum transportable length is 12 meters. So thus it combine the 4 segments will combine you maximum up to this portion. I can say in the stack up to this portion you can transport directly. Okay, you cannot transport the entire members from 6 to 14 directly. You have to take it. Yes, tell me. Clear?
Clear, sir. Clear.
You have to transport the length up to maximum 12 meters or 9 meters depending upon that. And 9 and 12 are multiples of 3. That is why I am dividing the entire member on 3 meter segments. Because 9 and 3 are multiples of 3. Some countries may follow 9 meter maximum transportable length. Some countries may follow 12 meter maximum transportable lengths. That is why I am taking the entire rafter column into 3 meter segments.
It is depends upon transportable length. Is that
Yeah,
so?
exactly.
Okay.
Transportable lengths. And the advantage is that you can get economical section.
Okay.
Fine. So I'm going to the stat editor. After this portion, just I'm saving my structure. So this is how stat editor looks like, what we have seen in the last beam design session also. These are the joints or nodes what we have created at a particular some particular points. Just okay, yeah. These are beam incidences. Nothing but first beam is connected between 4th node and 7th node. If you click here, Shift N. So this is the first beam, right? It is connected between 4 and 7. So that is what it is showing here. 1 is in between 4th node and 7th node. 2, second beam is in between 7th node and 1st node. Like that, it has created beam incidences for all the structure. And we have created a material because all these materials are, all these properties are predefined. Poisson's ratio, elastic modulus, density, alpha is nothing but thermal coefficient. Okay, so damping coefficient, all these are predefined parameters. That is why I have created a material property in the UI itself. And then end defined material, after that I'm going to give properties for each and every segment. So before that, for my convenience, I'm giving the units in mm because all just give me a minute. It is I'm taking the node numbers off here. Okay, so what is the units here? Predefined units, unit meter kilonewton. But if you follow meter kilonewton, you have to give in the decimal points, right? 0.4 or 0.8 or 0.3, like that. Okay, for my convenience, I'm changing the units. As I told you in the last class, you can change units at any portion in the entire stat editor you want. Okay, you can change it in any portion. Units, mm, kilonewton. Load units I'm not changing, and length units only I have changed it to mm, nothing but millimeters. So okay. As I told you, the simple frame, this is the simple frame, just I'm taking you to, just I told you, this one I'll design in AISC. So, and the next measurement frame is there, no? That we'll do in AISC and we'll compare. So, okay, member property, American. Okay, member property, American. Because this is a symmetrical frame, the property of member 1 will be applicable to property of member 3, right? Because we are designing it as a symmetrical frame. So the properties on either side of symmetrical axis will be the same. So suppose 1 and 3 are having same properties. So 1, 3 space. I told you in the last class, what is the syntax here? Tapered. Okay, I section is tapered. Tapered is nothing but you can provide different depths at the start and end point of a particular segment or a beam. Okay, just I'm clicking Shift E again. If you see beam 1, it is starting, it is having starting point at the top, ending point at the bottom. So 1, 3 tapered, starting point should be haunch portion, right? This is the haunch portion. Okay, so I'm giving higher depth. Suppose let us take 800 mm. So including the thickness of flange, I can take 8 mm thickness of flange on both sides. So 816, 800 plus top thickness or outside thickness of the flange is 8 mm. Inside thickness of the flange is 8 mm. The web depth is 800. 8 plus 800 plus 8. The overall depth will gives you 816. Suppose let us take web depth, web thickness as 8 mm. Okay, you can take as your wish. This is all trial and error basis. Okay, you have to give some particular section. You have to check whether it is passing or not. If it is passed, okay. If it is failing, you have to change the section until it passes. Like that we'll do. If any section passes heavily, you have to change it to the economical section. Otherwise, you have to reduce the section. Okay, like that we will do in this section. So 816, you can say something 666. Otherwise, because I'm taking the depth as 650 at the portion. Okay, 650 plus 8 mm outside flange, 8 mm inside flange. 650 plus 8 plus 8, 666. 200 mm outside flange width, 8 mm outside flange thickness, 200 mm inside flange width, 200 mm inside flange thickness. So, do you guys have any doubt in this syntax? How it has written tapered 8168, 666, 208, 208. So, is it clear to all of you?
Yes, sir.
If you don't mind, repeat again this taper.
Sure. Okay. 1, 3 are, if you see here, 1 and 3 are symmetrical, right? So I'm using the same property for symmetrical segments 1 and 3. These are beam numbers. 1 and 3 are beam numbers. Just I'll zoom in for you. You guys can see. It is clear to you. Okay, 1 and 3. Tapered means this is the prismatic section property we rapidly use for properties of I section. So tapered is the syntax, and then 816. 816 is nothing but, if you see here, green color portion is starting point of the first beam, blue color portion is ending point of the first beam. So obviously in the PEB building there will be more. Okay, just before that, just I'm doing with pinned base. Okay, I'm doing with pinned base for this building. Okay, pinned base will have negligible moment at the bottom and maximum moment at the top for this column, right? So you have to provide maximum section at the top of the column, right? So this is the green color portion. You have to provide maximum section. Suppose it is all assumption. Okay, all the PEB dimensions you have to give by assumption. This assumption will comes you by experience. If you do practice well, you'll get to know how much depth you have to give for this much of height, for this much of width, how much depth you have to give for a rafter. Like that, you'll get to know by experience. I am assuming 800 depth at the top of the column. Okay, and 650 depth at the end of the first beam. Here, if you see, it is the end of the first beam. I am taking the depth as 650 mm. So top is 800 mm, 800 mm, but I have written 816. Why I have written 816? This is the overall depth of the portion. 800 only is the web depth I have taken. 8 mm outside flange. Okay, if you have still doubt, I'll draw. Otherwise, I can take an example. Yeah. Suppose this is the I section, right? So this web depth I have taken. Okay. This web depth I have taken 800 mm. This flange thickness 8 mm. The inside flange thickness is 8 mm. So like that, 800 plus 8 plus 8. So obviously the overall depth of the section will be 816. Okay, 816. And then the next syntax will be for thickness of the web. Okay, what is the thickness of the web? This is the right. This is the thickness of the web. Okay, that I have considered, I have assumed it as 8 mm. And depth, second depth or end depth of the beam. This blue color portion you are seeing for beam number 1 is end depth. Okay, that is I have taken 650. Again, outside 8, inside 8. 650 plus 8 plus 8, that gives you 666. And 208 for outer flange. Otherwise, you can see, you can observe in the drawing. Okay, 200 by 8 I have written now. This width is 200. This thickness as 8. Inside also, this width as 200. This thickness as 8. That's how I have taken this syntax. So is this syntax clear for you? Starting depth, ending depth, in between the two depths, depth of the web. And the remaining portion, outside flange, inside flange. Generally, right? 200 by 8 plates, flange plates. 200 by 8 inside flange plate. So okay, is it clear now?
Yes, sir.
Yeah. So in the same way, I'm giving for 2 and 4 beams also. What I have ended here, I have ended with 650, right? So second segment will start from 650 because it has to maintain uniform shape, right? So here I have provided 800. Here I have ended with 650. So the second beam starting depth will be 650. So it will again starting with 666. I can change the thickness of web here as per my requirement. Suppose I am giving 5, or you can give 6. Anything if you want, you can give. And suppose I'm the depth of the web bed base plate we have assumed, right? Out to out or something, anything minor won't matter. We have assumed 300 depth of web, right, at the bottom while calculating center line diagram, right? 300 depth. So 300 plus outer flange is 8 mm, inner flange is 8 mm. So that is 316. So that is how you have to give sections for a column. So is this clear now, right? Any doubt you can ask me because I'll get to know whether you are doing or you are listening or not. I'll get to know by asking the doubts only. So I have completed for mainframe columns and I'm going to take internal column. So I told you in the last class, if any line you are starting with asterisk symbol or star symbol, it will be commented line. So it will not compile in the program. It will not run in the program. So you can do whatever you wish, right? You can write here whatever you wish. Just I have mainframe columns. I can say main columns. I have completed. Now internal column is there. I have to give section for the internal column. Internal column. So this is only one portion is there. Only one segment is there. What is the number of beam? It is 5. And again section tapered. Suppose let us assume the depth of suppose all these are assumptions, right? You know, all the designs should be assumption. If it is passes, okay, then otherwise you have to change. Okay, so the depth of the web is 400 for this one. Okay, so again I can take 8 mm inside or 8 mm outside, so that gives you 416. Okay, generally for internal columns we will not provide tapered. Okay, please be clear that we will not provide tapered columns for internal columns. Okay, we will provide straight sections only. Okay, 416, 416, 208, 208. Okay, one thing I want to tell you again, if both are same, nothing bad, outside flange and inside flanges are same, no need to give outside flanges because both are same. It will take 200 by 8 for both automatically. No need to give 2 times. Okay, if you give also no problem. You can give like this, but there is no meaning. Okay, because anyway we are giving straight section. We should not change the thicknesses on both sides because it will be symmetrical, right? The thickness on the left side will be the same for the thickness on the right side. So we should not give different thicknesses on both sides for straight columns. So that is why I'm not giving 2 flange thicknesses or flange plates here. And I have completed columns here. I'm going to take rafter sections. Okay. So 6 and 23 will have similar section because we are talking about this as symmetrical. So 6 and 23 members will have same sections. 6, 23 tapered. Suppose what I have assumed while doing the clear height. Have you forgot? I have taken, suppose they have given, if you see here, they have given 6 meter clear. I have taken 6.4 for center line in the stat. So I have assumed the rafter depth as 800 mm. So by accurately, I can give 816. I'm assuming top thickness and bottom thickness as 8, or otherwise you can assume 820 top thickness and bottom thickness, 10 and 10. Okay, 820, 8, 720 because I'm doing tapering here. Okay, 720, 208. In the next 7, and obviously what is the member before 23? It is 22. 7 and 22 tapered. It has ended with 720, right? It has started with 820. It has ended with 720. So the next member should start with 720 again. 720. Suppose this has take 620. 208. Okay, you can give top and sorry, I have assumed 10 mm, right? Okay, you can give top and bottom thicknesses differently. You can give if you want. But for the time being, for the practice, I have taken the same. You can change if you want. Upper 620, 620. I'm giving the straight section because the width is more here. It may fail in deflection. If you much reduce the section, the rafter may fail in deflection. So that's why I am giving the straight section from here. I'm not much reducing the section. Just I'm copying all these things. So up to what number I can copy, right? Yeah, the interesting portion is here. Okay, just before 15 minutes, I told you that we have to provide a flat bottom section in order to sit the column properly, right? What is the I can say what is the roof slope here? 1 in 10 we have assumed, right? So this member length is approximately 3.28. Okay, 3.28 meters, and the slope is 1 in 10. You have to give flat bottom. So what is the depth change you have to made here? What is the end depth you have to give here? Can anyone guess? because I am following 600 depth up to member 16. You see here, okay, one more line I am copying. 13, 16, control V. Okay, so I have maintained 600 depth up to this portion. So how much depth I have to give here in order to get a flat bottom? All these are geometrical calculations. Please be active to do this. Okay, simple, right? All this.
900.
Yeah, tell me. 900. Yes, exactly 900. Why it is 900? Okay, actually here the member length is 3.28. Okay, but 0.28, okay, you can make it negligible. Okay, actual length is 3 meters, right? 3 meter for 1 in 10 portion. If you do calculation, 3 into 1 by 10. So what is the depth you have to maintain on the other side is 300 mm, right? In order to get the flat bottom. Already we have given 600 here. So in order to get the flat at this portion, you have to increase the depth by 300. So 600 plus 300, it gives you 900. 14, 15, tapered, 26, 20, 200. Sorry. I think where is the starting and ending? 14 starting is 620. Yeah, 620 and ending is 920. Okay, please be careful while giving the depths, whether it is starting or ending. Please be careful with this. This is the starting depth, this is the ending depth. Starting is 600, ending is 900. So that's why I have given 600 first, I have given 900 next. So okay, so everything has been completed up to material property. So after that, it has already constants, material, steel, all these are there. And then again, you can change units to meter kilonewton. This is the default unit. Okay. This is the default unit coming here. Actually, if you see, meter kilonewton is the default units, input units. But I have changed it for my convenience. So after my program ended, I have changed units to meter kilonewtons again. Clear? So meter kilonewtons. And then you have to define supports. So all the 3 nodes I'm taking as pinned supports. So the starting and ending portion is completed. Again, I'm clicking Shift E so that the starting and ending points will disappear. So I want to know the node numbers only. I have beam numbers here. So I'm taking beam numbers off. I have to node numbers on. Shift N. If you click Shift N, node numbers appear here. 1, 2, and 3, right? So 1, 2, 3. What is the support I am giving? Sorry, pinned. So supports also I have given. So the next section is you have to give loads. Okay. We are doing AISC design in this section, in this session. So that's why this complete loads will be given. Suppose, yes, before going to that, one more portion I need to tell you. So, okay, what are the loads to be given? So, first load, generally I follow this order. Okay, what is your favorite order you can follow? I'm again telling you, I'm following the order which I'm writing here. First load, load 1, seismic in X direction. Seismic in positive X direction. Okay, I'm doing 2D frame only here, right? Okay, I'm doing 2D frame only. So in 3D frame, actually, seismic is a lateral force, right? Seismic forces are lateral forces. So it will cause in X direction, or otherwise it will cause in Z direction. But we are doing plane frames here. So that's why there will not be any Z directional force, because it is a 2D frame. Okay. For the 2D frame, also one more thing, you have to change the stat space to stat plane, like all the like I told you in the last class. Okay, plane is nothing but 2D. It is for 2D frame. Okay, if you give space, you can apply Z forces also. In this program, I'm not applying any Z forces. That is why I'm doing it as plane frame. Okay. Okay. And the next thing, seismic in positive X, and the next load 2, seismic in negative X. Okay, obviously, right? So if I take this structure, seismic forces will cause effect in this direction and in this direction also. You cannot directly tell, right, whichever direction it acts, right? Because we can give only one direction in the plane frame. So whether it should be plus X or minus X, we cannot tell directly. So we have to apply both the cases. So plus X and minus X. And the load 3 will be dead load, and the load 4 will be live load. All these you know, right? Load 5 will be collateral load, or some people will call additional dead load. Okay, you can say it as collateral load or additional dead load. So what is dead load? Dead load is self weight of the structure, including sheeting, purlins, etc. So what is the live load? If any person goes over the structure for maintenance purpose, like that, any live load. Okay, what is the collateral load again? Collateral load generally call it as additional dead load. Additional dead load is nothing but some clients may want ceiling below the roof, because it is a steel building. They have to provide ceiling to reduce the thermal effect. Generally in summer season, there will be much more heat, right? So in houses also, you'll do ceiling to reduce the heat. Like that only in industrial buildings or warehouses, any PEB structure, some clients may want ceiling below the roof. Like that, any supporting structures, not only ceiling, any supporting structures below the roof comes under additional dead load. And all these gravity loads completed. So, and the load 6 will be wind load 1. Okay. So in the starting, I think third class or fourth class, we have discussed about wind loads. At that portion of time, I told you we have to apply wind load cases in 6 cases, right? Anyone have remembering that? I told you, I think in the 5th class or 6th class, I don't know particularly the number of the class.
जीरो डायरेक्शन बेंड और 90 डायरेक्शन बेंड के लिए और
sorry
जीरो डायरेक्शन बेंड और 90 डायरेक्शन बेंड में दोनों
एग्जैक्टली दोनों मतलब I mean pressure case positive X, pressure case negative X, suction case positive X, suction case negative X, and longitudinal 1, longitudinal 2, right? Yes. Understood?
Yes sir.
Yeah. So those are the 6 load cases generally we apply in the PEB. Okay, some people will apply 8 load cases also. Nothing to worry about. But practically 6 load cases are sufficient. Load 8, wind load 3, load 9, wind load 4, load 10, wind load 5, load 11, wind load 6. So first, we have applied seismic forces, and then we have applied gravity loads, and then we have applied wind forces. And the last thing, what is remained here? Anyone guess please, because you are following the classes, right? So temperature load. In the first class itself, I told you temperature load application on the steel is must, because temperature will have the tendency to expand or contract according to the changes in temperature, right? Steel have tendency to expand or contract according to the temperature changes. If there is increase in temperature, the steel has a tendency to expand. If the decrease in temperature or below the freezing temperature, it has a tendency to contract. So those forces, generally we call them as self-straining forces. Okay. Self-straining forces means we are not applying any forces on the structure externally. These forces will these forces will be applied itself by the structure due to temperature changes. Okay, this comes under behavior of the steel. Okay, so these are self-straining forces. Two. One is above room temperature, one is below room temperature. So these are the loads, primary load cases, I can say, not loads. These are the primary load cases we generally apply in a steel structure. Clear? Up to this, all of you are clear, right?
Clear, sir.
Okay, I think we have 10 more minutes, right? We cannot complete if we start. Yeah, yes, tell me, tell me.
Sir, what about crane load? Any equipment load?
Just I told you in this starting of this session itself, we are not going to analyze the big structures directly. This is the sample. Okay, this is the sample structure. That's why I have taken example as just rigid frame, simple rigid frame. I'm going to increase the what I can say, increase the criticality. Okay, I'm going to increase the criticality over the length of the time. Okay, this is simple mezzanine frame. In the next section, or after the next session, we will see mezzanine. After that, we will see crane. After that, any other special structure like flat roof structure or truss structure. Okay, so like that, we'll increment the critical. Clear? Because all the people most of the people comes under basics, right? That is why I'm going to take from the basics itself. So that is why. Right. Okay. Clear? Don't worry. I'll cover the crane frames also, and crane beam also I'll cover. Okay. Generally, we'll do crane frame directly by use of brackets. Okay. So how to design a crane beam? Okay, we can call it as generally runway beam. How to design a crane runway beam also, that also I will cover. Okay, that is by using moving loads. Moving loads concept. How to give moving loads on that while designing, I'll tell you. So just 10 more minutes. So if we start this loads concept, it is much more larger concept. It will take a lot of time applying here. So we have not much that time today. So I want to stop here. Meanwhile, you can ask any doubts. Just you can understand, guys. If you practice only, you can understand all these things. If I tell you in this session, after the next session, if you come with fresh faces, so you cannot understand, because I have taken syntax like this. So there is a chance of forgetting this syntax type if you do not practice tomorrow. like that. Okay, so I'm advising that please be practice all these types. Okay, not frames. Okay, just now I have started the frames. Just you can throw the syntax on the beam. So syntax is anywhere syntax. There is no change, right? You can throw this syntax on the beam itself, and you can change the difference. You can change the types of sections. All these you can practice by your own. If you have any doubt while practicing, because doubts will come to know if you practice only. You cannot observe directly here, because I am the only person doing here. You cannot observe directly. So if you practice well, and you'll get much more doubts. Doubts will lead into knowledge transition. So can I stop here today?
Okay, sir.
Okay.
Sir,
So,
I want one
yes,
question.
yes, tell me.
Sir, please open slide model.
Model.
Slide yes, sir.
Okay.
How to check utility in this frame?
How to check
utility?
Which utility you want?
Sir, unity, sir. Actually,
Unity check ratios you want?
Sorry, sir.
I have not designed it yet.
No, other frames. I have used a DATI already, but in this.
No, I'll tell you. No, not this one. It has not completed yet. Do I have anything in this? Yeah, this has not been completed. So you'll get utility ratios after designing only. Just he's asking the doubt, that's why I'm telling him. Okay, please don't bother about this utility ratios, remaining persons. Okay, please don't bother about utilities ratios because it will create these utility ratios will be created after the design only. Okay, if you click right click here, you can see structural diagrams. There are several methods available. I'll tell you. If you right click here, structural diagrams option is available. In that, design results portion is there, no? If you click show diagram based on actual ratio. This is called unity check ratio. If you click OK, then you can see 1.25, 1.24.
Yes, sir. Okay.
Okay. And the example I have taken it because if you see here, all these rafters are failed, right?
Yes.
More than one. Ratios are more than one.
Yes, sir.
Okay. So it is failed actually. But if you check this frame in a licensed version, it has passed. That is why I am advising to use licensed version only whenever possible. If there is no possibility, we cannot do anything. But I am advising to use licensed versions only because I have checked this frame in the licensed stat version. It has passed all the members. Why I don't know. There is something problem in the cracked version. Okay, so I'm advising all this. Okay, the other thing, you can check unity ratios in the post-processing mode. If you go to post-processing mode, if you click OK here, there is direct option, utilization ratio here. Okay, if you uncheck displacement, you can see unity check ratio. Clear. So this is all about. Right, your doubt is clear?
Okay, sir. Thank you, sir.
Okay, thank you. So if
one
you
more
are,
question, sir.
Yes, tell me.
एक्चुअली सर मैं जानना चाहता था कि एक्चुअली लाइसेंस वर्जन का कॉस्ट क्या आता है? हमें तो पता नहीं सर कहां से इंक्वायरी करें, इसलिए आपको पूछ रहा हूं।
कॉस्ट क्या है वो तो मुझे भी पता नहीं, हम लोग ऑफिस में यूज करते हैं ना, ऑफिस में सब नेटवर्क लाइसेंसेस है, इसीलिए
तो हमको
इंडिविजुअल
तो कहाँ
लाइसेंस
से,
का कॉस्ट पता नहीं मुझे।
तो हमको तो सोर्स ही नहीं है, कहाँ से पूछें कि इसका प्राइस। मैं
Bentley, you can contact direct Bentley. They will welcome you. Bentley.
ओके सर।
You can visit Bentley site. Okay. Okay. So clear, all of you. So again, I'm telling happy Ugadi to all of you. Though it is late. Okay, happy Ugadi to all of you. Enjoy the festive season and happy Ramzan month to all of our Muslim brothers and sisters. So happy Ramzan month to all of you. Enjoy the festive season and may all you be blessed with plenty of knowledge, everything. So happy Ugadi and Ramzan month to all of you. So if you are all okay with this, I'll wind up this session as of now. Okay.
Yes,
Fine.
sir.
Okay.
Thank you all. Thank you all for joining. Thank you. Bye.